Hi, welcome to section 10.4, adding and subtracting radical expressions. Hopefully by the end of this, you will be able to add and subtract radical expressions. So how do I add or subtract a radical expression? First off, the first thing you're going to do is simplify. So simplify every single radical first. Then you can find like terms. So the only ones that you could add or subtract are like radicals, and like radicals have the same index, so that's like the type of radical. They're both square roots or they're both cube roots, that kind of thing. And they have the same radicand. That's the thing underneath the radical. So the cube root of 2 and the cube root of 2 could be added, or the square root of 5 and the square root of 5. You're looking for the same type of root and the same thing underneath the radical. Once you identify which ones are like terms, you can add or subtract. And you add or subtract the same way you do with variables. So you're going to add or subtract the coefficient, that's the number in front of the radical, and then you keep the radical part the same. So let's do a few of these. In example 1, the first one I have is 2 square root of 11 plus 3 square root of 44 minus the square root of 11. So square root of 11 can't be simplified too much, but the square root of 44 can. So 44 is 4 times 11, and 4 is 2 times 2. So I've got a pair of 2's that I can bring out of that radical. And when I bring it out, there's also a 3 there. You'll just multiply those together. This 2 times that 3 would be a 6. And then underneath the radical is this 11 that we haven't used yet. Okay? Everything else stayed the same, so we have a 2 square root of 11 plus 6 square root of 11 minus the square root of 11. So you can see how important that simplifying step is so that we can actually identify which ones are like radicals. From here, all of the square root of 11s are like terms, okay? They're like radicals. They have the same type of root. They're all square roots, and they have the same thing under the root. They're all square root of 11s. So if I'm adding them, 2 plus 6 would be 8, minus 1 would be 7. So I will have 7 for the coefficient, and then the radical part stays the same. This would be just like if you had 2x plus 6x minus 1x would give you 7x. You wouldn't change the x part of it. You would just add or subtract the coefficient, and you do the same thing here. Okay? Let's do another one. In part B, I have the cube root of p to the 4th q to the 7th minus the cube root of 64pq. Right now, neither one are the same, are they? They're not like radicals, but both of them can be simplified. So the p to the 4th, q to the 7th. The p to the 4th means I've got 4 p's. The q to the 7th means I have 7 q's multiplied together. 1, 2, 3, 4, 5, 6, 7. And the cube root means I'm looking for groups of 3. Okay, so I've got 3 p's. I can do the q's twice. I can do 2 groups of 3 q's. And so the things that I can bring out of the radical go in front. So I'll have a p. And then I'll have 2 q's, which would be q squared. And it's still a cube root. That didn't change. And the things underneath the cube root are the things that didn't belong in the group. So I have 1p and 1q left. Okay, so that's the simplified version of the first one. Second one, let's see, 64 is 8 times 8. And 8 is 4 times 2. And 4 is 2 times 2. And again, we're doing cube roots, so I'm looking for groups of 2, or groups of 3, excuse me. And I have 3 2's twice. So I have 2 of these groups of 2 that I can take out. When I take them out, I'll just multiply them together. So this 2 times that 2 would be a 4. 1p and 1q is not going to make a group of 3, so they will stay underneath my radical. So there's the simplified version of the second radical. Now that I've simplified both, they actually are like radicals. They're both cube roots, and they're both the cube root of pq. So they are like radicals, so we can subtract. The only thing is that these coefficients aren't really like terms, so the best that we can do is, I mean, we can still subtract them. We can do pq squared minus 4, And I'm just going to put them in parentheses and say that's multiplied by the cube root of PQ. That's the best I can do, because I can't really combine things that aren't like terms. All right, one more. Part C, I've got 2 times the 4th root of 32 minus 7 4th root of 162. Well, let's see here. 32, well, that would be 8 times 4. 8 is 4 times 2, and 4 is 2 times 2. Okay, so really I've got 5 2's here, but it's a 4th root, so I'm just going to get a group of 4 2's. So 1, 2, 3, 4. Here we go. I can take a group out. When I take that group of 4 2's out, it'll multiply by the 2 on the outside. 2 times 2 would be a 4. 4th root of, and then the little 2 here that wasn't part of our group will go on the inside of my radical. All right, let's see. What about 162? Let's see. 162 is 2 times 81. 81 is 9 times 9. 9 is 3 times 3. And when I'm doing a 4th root, I'm looking for groups of 4. I've got 4 3's that I can take out, and that group of 3 multiplies by the 4, and that'll give me a 12. And then underneath the 4th root will just be this little 2 that we hadn't used yet. Okay? That didn't get to be part of a group. Now that I've simplified, we can actually see that they are like radicals. They both are 4th roots, and they are both 4th roots of 2. So they have the same index, they both have 4's, and they have the same radicand, the 2's. So I can go ahead and subtract. Since they're like radicals, 4 minus 12 would be negative 8. And the radical part stays the same. It's the 4th root of 2. So that would be the answer for that one. All right, next one is a little question for you. Is the square root of a plus the square root of b, is that the same thing as the square root of a plus b? So that's our question. So sometimes when you have these questions, let's say this was like a true-false question, you're like, I don't know, does that work or not? One way you can test it is just to give a couple of points, try a couple of values and see if it works or not. So we're going to try if a is 1 and b is 64, just a couple of perfect squares just to make this easy on ourselves, okay? So we're going to evaluate the square root of a plus the square root of b if a is 1 and b is 64. So let's see, if a is 1, we'd have the square root of 1. If b is 64, we'd have the square root of 64. The square root of 1 is 1, and the square root of 64 is 8, and 1 plus 8 is 9. All right, let's try the other side, the square root of a plus b. Same numbers. So we'll have a is 1, and b is 64. Well, this time I need to add first because they're both underneath the square root. So we're going to add 1 plus 64, which would be 65, and then we'll take the square root. Well, that one's not a perfect square, is it? So if you took this, sometimes it's nice to just type it in the calculator and see what you get. If you did a decimal approximation, this would be about 8.062. And so you can see, here's our exact answer, here's an estimated approximation. You can see those are not the same. So we can basically conclude by this little counter example that the square root of a plus the square root of b is not the same thing as the square root of a plus b. All right, now it is your all's turn. You get to try one and show me how much you've learned.